The goal of this video is to teach you how to evaluate the arc sine, arc cosine, and arc tangent functions. This is the arc sine, also it's known as the inverse of sine. This is the arc cosine, or the inverse of cosine. This is arc tangent, or the inverse of tangent. And these are the types of expressions that we'll be evaluating today. Now, arc sine, it's a function, so each input has to have exactly one output. The outputs for arc sine have to be in between negative pi over 2, so from 0, here's negative pi over 2, all the way to pi over 2. So your answers to arc sine are angles in the first or fourth quadrants. Now, sine of an angle is the y-coordinate of where the angle intersects the unit circle. So this 1/2 represents a y-coordinate on the graph. So here there's a y-coordinate of 1/2, and there's also a y-coordinate of 1/2 there. You should know that the sine of 5 pi over 6 is 1/2, and so is the sine of pi over 6. Now this can only have one output, and as I said before, the output has to be in the first or fourth quadrant. So it'll be this angle right here, pi over 6. Arc sine of negative square root of 3 over 2. So you see arc sine, this is a y-coordinate on the unit circle. This is where the unit circle has a y-coordinate of negative square root of 3 over 2. There's also another point over here. I don't have that labeled because arc sine can only output angles in the first or fourth quadrants. Now, if I start from 0 and go counterclockwise, this angle here is 5 pi over 3. And it is true that the sine of 5 pi over 3 is equal to negative square root of 3 over 2. But our answer has to be in between negative pi over 2 and 0, so I can't go beyond pi over 2. So starting at 0 here, I'm going to go clockwise to negative pi over 3. So the sine of negative pi over 3 is equal to this negative square root of 3 over 2. Now we have arc sine of negative 1. So we're looking for a y-coordinate in the unit circle of negative 1. There's only one location for that, it's right here. Now it is true that the sine of 3 pi over 2 is negative 1, but this answer has to be in between or including negative pi over 2 to positive pi over 2. So it's going to be this angle here, negative pi over 2. The sine of negative pi over 2 equals negative 1. Now let's pretend we didn't have the unit circle. It's the same problems, but here's how I would do it. I'm going to sketch a little unit circle there. Now I'm going to draw 2 points in the circle that have a y-coordinate of 1/2. Now, arc sine can only output an angle in the first or fourth quadrant, so the answer cannot be the angle in red. It has to be the one in blue, and so this angle is pi over 6. Arc sine represents the y-coordinate on the unit circle. There's a point down here where the y-coordinate is negative square root of 3 over 2, and the other one is here. The arc sine cannot output an angle in the third quadrant. It has to be the first or fourth, so it'll be this angle here. Again, the answer cannot be past pi over 2, bigger than pi over 2. So I'm going to start at 0 and go clockwise. That angle is negative pi over 3. So I'm not looking at the unit circle because I have to have this memorized already to understand what these outputs are. Now, again, arc sine is the y-coordinate on the unit circle. There's only one location in the unit circle with the y-coordinate of negative 1. It's right here. The answer is not 3 pi over 2. 3 pi over 2 is going beyond pi over 2. So starting at 0, I go clockwise, and the answer is negative pi over 2. If you want to understand why the outputs have to be between or including negative pi over 2 to pi over 2, watch the video that I'll have a link to at the end of this. Okay, arc cosine. Now, arc cosine is a function as well, so there can only be one output. Now, arc cosine will output angles in the first and second quadrants. So when you see arc cosine, the answer has to be in between 0 and pi. It can include 0 and pi, but somewhere in between there in the first or second quadrant. Arc cosine will output an angle. The answer is an angle. And this represents an x-coordinate on the unit circle. So we can see right here, there's an x-coordinate of negative square root of 3 over 2. There would also be another angle here. I don't have that labeled. I don't have any of them labeled because arc tangent of x, arc sine of x, arc cosine of x cannot output an angle in the third quadrant. None of them can. So this angle here from 0, this is the terminal side of the angle. It's 5 pi over 6. You should recall that the cosine of 5 pi over 6 does equal negative square root of 3 over 2. Arc cosine, this refers to an x-coordinate of a half. That's going to be right here. Oops, that's negative half. Positive half is right there. There's another one right here, but I can ignore the fourth quadrant because arc cosine has to output an angle in the first or second quadrant. So if I start at 0 and I go here, that's pi over 3. So the output for arc cosine of a half is pi over 3. The cosine of pi over 3 equals a half. All right, arc cosine of square root of 2 over 2. So I'm looking for an x-coordinate of square root of 2 over 2. There's one here. This point here has an x-coordinate of square root of 2 over 2, and so does this point. But arc cosine has to output an angle between 0 and pi, so it must be this answer here in the first quadrant. That's pi over 4. All right, now let's do these problems as if we didn't have the unit circle in front of us. So I would look at this and go, okay, this is an x-coordinate because that's arc cosine. An x-coordinate on the unit circle. So it's negative square root of 3 over 2. Now there's also another point here. There really is no need to draw this because this answer can't be in the third quadrant. So my answer is that angle there, which is 5 pi over 6. Arc cosine of a half. That's when x equals a half. I have these locations here on the unit circle where the x's are half. But our cosine has to output a value between 0 and pi, so this answer will be pi over 3. Our cosine of square root of 2 over 2. I know that the cosine of pi over 4 equals square root of 2 over 2. So this will be our angle right here in the first quadrant. That is pi over 4. All right, last but not least, the arctangent function. Now, if you remember, tangent of angles are equal to the opposite over adjacent, or the y over the x. It also represents, the arctangent represents the slope of the angle. So when I see this input of negative 1, I'm thinking, which angles have a slope of negative 1? Now, I didn't mention this yet, but arctangent can only output an angle in the first or fourth quadrant. So I don't know if you noticed, but I'm using all three colors here that I use for arc sine, arc cosine, and arctangent because all three inverse trig functions output angles between 0 and pi over 2. But only arc cosine outputs angles from pi over 2 to pi. And it's arctangent and arc sine that output angles also in the fourth quadrant, but specifically between negative pi over 2 and 0. So our answers for arctangent will be in the first or fourth quadrant. Arctangent will not include negative pi over 2. That's impossible. It won't include positive pi over 2 as well. Again, there'll be a video at the end that will explain, if you want to watch it, why the outputs for arctangent and arc cosine and arc sine are in the intervals I'm describing today. So we're looking at the angles with a slope of negative 1. This y-coordinate of negative square root of 2 over 2 divided by square root of 2 over 2 would be negative 1. So our answer to this problem isn't going to be 7 pi over 4. That's out of bound. That's beyond pi over 2. It's going to be right here at negative pi over 4. Now, I'm not sure how familiar you are with negative square root of 3 as a slope, but a negative slope from left to right, it's decreasing. The line would be decreasing under this angle, these angles here. And if I took this y coordinate divided by that x, I would divide negative square root of 3 over 2 by a half. And so if you multiply by the reciprocal, the 2's would cancel and you get negative square root of 3. So our answer isn't going to be 5/3 pi. Sure, that'll end up right there, but that's beyond pi over 2. So we're starting at 0 going clockwise, and this angle is negative pi over 3. Now, I'm not sure if you recognize this slope. So again, arctangent, this value here is a slope. 1 over square root of 3 is the same as the square root of 3 over 3. So maybe you recognize that. If you rationalize this denominator, you would get square root of 3 over 3. Now that'll be the angle pi over 6. There is an angle here that also shares that same slope. There's angles here, but it'll be this angle because arctangent has to output angles in the first and fourth quadrant. So the answer is pi over 6. Now let's do these 3 problems as if we didn't have the unit circle in front of us. So this says the arctangent of -1. So I draw an angle here, the slope of -1, and an angle in the fourth quadrant. Knowing that arctangent has to output angles in the first or fourth quadrant, the answer can't be the one in orange. So starting at 0, I go this clockwise here, and that's negative pi over 4. Now I'm going to draw an angle, or angles, with the slope of negative square root of 3. It's going to be a little bit steeper because the square root of 3 is a larger number than 1. So the slope, negative square root of 3, will be steeper than the angle with the slope of -1. Again, arctangent cannot output a value bigger than pi over 2. It also can't output pi over 2. So I'm going to go here, and this would be too far over. That's out of bounds. So if I go back to 0, this angle here is negative pi over 3. Arctangent of positive 1 over square root of 3. So arctangent, the answer to these problems, all these inverse trig functions, will be angles. This, because that says arctangent, represents a slope. So here's an angle with a slope of 1 over square root of 3, and here's the other location of the angles with a slope of 1 over square root of 3. This is a positive slope line. If I draw a line right here, arctangent of 1 over square root of 3 will be pi over 6. All right, I hope this video helps you to evaluate inverse trig functions. In the description, I'm going to have some more practice problems for you. There's 6 questions there on this topic. In addition, on the second page of that PDF are the solutions, and there's also a video for you to watch on, if you need to how to get those solutions. All right, thanks for watching.